So I just wanted to welcome everybody to the webinar today, and thank you for joining the webinar. My name is Denise Brown, and I'm the program manager at North Dakota Local Technical Assistance Program, and I'll be hosting the webinar today. So today we have Daniel Gillian with us to share his knowledge on the science and art of how to use brine. He has quite an extensive background in the snow and ice control. He started using liquid for anti-icing in 1996. In 2003, he earned his designation as a certified snow professional from the Snow and Ice Management Association. He served on the board of Snow and Ice Management Association for 6 years and was the chairman of the board in 2011. He founded CrewTrack Software in 2005 as a snow fighter, US a top 100 snow company. In 2012, he began education and training for liquids. So he's been doing this for a while. Daniel is currently employed by Camion as a trainer and educator of liquid anti-icing. Resources that you can tap into as well are on the North Dakota LTAP website under resources and snow and ice control. One area that I would really point to is Clear Roads on there. They have great resources for you to tap into. So again, thank you. And we will go ahead and get started.
Very well. Thank you all for joining. Hoping that everybody can hear me okay. Patrick, can you hear me okay? Or Denise?
Yes.
Okay, very good. So as you can see here, I've kind of put in a little bit of a different name here, a proactive approach to snow removal. It's pretty much the same thing as what I call the art and the science of salt brine or the power of brine. All three titles I've used. This one I kind of changed a little bit just because I'm seeing more and more the need for us to start thinking of our snow removal in a proactive way. And we'll get into all of that as we go. Let's see here. For some reason now it doesn't want to advance. Let's see if I can figure out why. There we go. Denise mentioned most of this. The one thing I'll point out here is you notice this article here, that was about 120 pounds ago. So I'm kind of happy about that. So I've been doing nothing but snow since 1996, including a software program I wrote for the industry. And then I had a snow company that was a top 100 company every year of his existence as a private contractor. Of probably my most proud moment in that was I did 17 years of snow removal for Arrowhead Stadium and the Kansas City Chiefs, which obviously I'm a big fan. So this video I'll show you here just shows a little bit about our Camion equipment. The Camion equipment all comes on stainless steel skids, can be taken off and on of the truck pretty simply. We have high flow electric, which is what you're seeing in this video. Gets about 30 gallons a minute, about 34 to 36 feet in spread. We also have gas motors that has a higher volume, and then obviously our hydraulic motors have the highest volume. But this high flow electric has become probably close to 80% of our business. So just a little bit about that. So what is salt brine? Basically, the easiest way to explain salt brine, most of you know what it is, but I get this question quite a bit. Go look at ocean water, that's salt brine. You can't see the salt in it, but it's there. The same thing is true for the brine that we put on the roads and parking lots. You can't see the salt in it, but that's what makes it brine. It's so well, it's like microscopic sized particles of salt that work instantly. As you guys know, when we put down a solid product, it doesn't melt anything until it turns to brine, which is the huge advantage of using salt brine. So I want to spend just a few minutes going through some terms, and we did this in our in-person, because I think there's so much in here that people don't know. And I don't want to insult you if you do know these things. If we were in person, I would be asking these as questions. I'll try to go through it a little quicker since we're not. But all the terms that I have here that we're going to concentrate on are pretty important terms for our industry and how these chemicals and temperatures and all that work together. So the first one is eutectic temperature. Eutectic temperature is the lowest point at which any chemical is going to melt snow and ice. So our three main chemicals for snow and ice are going to be calcium, magnesium, and sodium. Sodium being the base of almost everything we use. Now, some of you may be using a blended product that you buy as a blended product, and so there are some other additives in those, like a salt brine or a salt brine, a beet juice or, something along those lines. But the basis is almost always going to be salt brine as the basis for your liquids. And even back in the early days, when I was putting things down in the late 90s, salt brine was the majority of the chemical, except for my very first treatment was straight magnesium chloride, and that was a huge mistake. So we'll talk about some mistakes as we go on. But so calcium chloride, what's eutectic temperature? -60. A lot of people aren't aware of how cold magnesium chloride will work. So with that being said, you can see it really never gets too cold for liquids. And as far as I know, we're using liquids in pretty much every state of the nation. A lot of Canada is using it, although Canada has been slower to adopt it. About the only state that I think doesn't use brine is Florida. As far as I know, they don't use brine, but pretty much every other state does. Magnesium chloride, -38 degrees Fahrenheit. The one that is the basis for everything, sodium chloride, -6 degrees. What kind of irritates me is I was listening to a scientist on the news here in Kansas City talking about salt works down to 5 degrees. And they were, it was when we got our one snow this year so far. And they were trying to talk about how the counties and the cities are using brine and and it works down to 5 degrees. And so I years ago when I sold my companies and I started working for these manufacturers and launching some liquid programs, got really frustrated with a lot of what has been going on in the industry, especially from those who manufacture the chemicals that we use, because there's so much misinformation. And I had been lied to for 15 years about what works and what doesn't work. And it all came from these manufacturers who were making a profit from their liquids, and they would not have sold their liquids had they been honest with the parameters, et cetera. So I think it's important for us to know these numbers because it's going to help us in determining what we use and when we use it. So eutectic temperature is pure science, right? It's repeatable, does the same thing every time. On the other hand, you have effective temperature. Effective temperature, in my mind, is part of the art. There's not a science. Science goes into it, but the only way we actually understand this part is by practicing it. So effective temperature could mean, is it effective cost-wise? Is it effective in the way that it responds to the surface temperature? Is it effective? Whatever that question is, you answer it in a subjective way. And so for the sake of our presentation today, I'm going to say that the effective working temperature of sodium chloride is 15 degrees above zero. So does that mean it doesn't work below that? Not at all. Does that mean that if it's 20 degrees, it's effective? Absolutely. So I think you'll find, and Denise mentioned clear roads. Clear roads is in the beginning, when I started doing presentations 8 or 9, 10 years ago, I got a lot of the data from Clear Roads, even though I'd had so many years of experience at doing it myself. And I found that in that documentation, most guys agreed that somewhere between 15 and 20 degrees was the effective temperature. So and I've actually found many guys since then who go below that. They'll say 12 degrees. Well, for the sake of the conversation today, we're going to say effective temperature is 15 degrees at the surface. Again, we're not measuring air temperature and we're not measuring ground temperature. Those two are at war with each other all the time at the surface, and that's the only thing we can affect is the surface temperature. So we can know what that surface temperature is, obviously, and if you use a lot of liquids, I would highly suggest that you have a temperature gun mounted on your mirror. You can get one that you stick out the window, which is what I used to use, but they're not super accurate because it's coming from a warm truck to an outside cold temperature. So we're going to say 15 degrees is the effective working temperature of brine. And we'll get in more to that as we go on. Endothermic. Endothermic, there's two types of chemicals that we're using here, endothermic and exothermic. Again, if we're in person, I'd ask you what one or ones are endothermic, but since we're not, I'll tell you, it's sodium chloride. So as you guys know, if you put sodium chloride salt on an asphalt parking lot, and right beside it, you put salt on a concrete sidewalk, your asphalt parking lot is going to melt sooner because the asphalt's absorbing the heat from the sun, causes the sodium chloride to work much quicker than it would on, say, concrete. So it absorbs heat. It has to have heat and moisture to start working. On the other hand, calcium and magnesium are exothermic chemicals. They produce heat. Matter of fact, calcium chloride, when it goes from a solid to a liquid form, it can produce so much heat to ruin your equipment or even melt your equipment. It gets very hot. It will obviously burn you. So when guys ask me about blending with, putting, say, calcium flakes into sodium chloride, I really discourage that because of the heat that it generates. And if you put a granular calcium chloride on a parking lot, obviously or a road or sidewalk, it causes that surface to get pretty hot because of that conversion. So it's an exothermic chemical producing heat. So when we do blends, basically what we're doing is taking the basis, which is an endothermic chemical, and we're adding an exothermic chemical to it to provide some heat for the endothermic chemical to work and for the endothermic chemical to get to lower temperatures. Hydroscopic. Hydroscopic is a term that's hugely important. I had two major failures with liquids. Both of them were because of this term. The first one, I was using straight mag chloride back in 1996 because to my knowledge, there weren't any blends back then and nobody really knew a whole lot about it. And so I put down straight mag chloride and I made my surfaces slicker than ice because the temperature, we got a lot of snow, but the temperature never got below 32 degrees and that mag chloride just got slick as could be. And then I had another instance where we pre-treated with a blended product with a mag chloride in it, and the temperature came up instead of going down, and we had major, major problems. We had two office buildings connected to that property, and both of those office buildings had to have all their floors redone, 14 floors, because it drugged so much of the product in and ruined the floors in the building, as well as slip falls. So hydroscopic's a big term. And as you guys know, if you've ever used granular ice melt, and I don't know why this is, but my crews, you'd send them out with a pallet of ice melt and they'd come back with half of them open. And you're going, what? Why can't you just empty all of those instead of opening new ones? Because if you don't seal that, by the next day, that bag of ice melt's a brick. And that's totally because of hydroscopic. It's pulling so much moisture from the air, which, again, a term you guys will understand is, that's why we use it for dust control. It causes the surface to stay damp and keeps the dust down. It does the same thing in the winter unless the temperatures are really cold. So hydroscopic is a big issue, especially with the blends. The next term is one I do want to spend a little bit of time with, and then we'll fly through the rest of the terms. Anti-icing. Anti-icing for most people, if you saw it on a screen, it'd be anti-icing equals pre-treating. But I disagree with that definition. I think that's a partial definition, but the term anti-icing actually says what it means. It keeps ice from forming. So this is where I come up with the term proactive. This is a proactive way to do snow and ice control, especially when we're pre-treating. If we're not pre-treating, guys, you're a reactive snow fighter. And when you have reactive snow fighting, you will almost always have ice to deal with. Because as you know, cars driving over that snow is going to pack it down into a hard pack or ice. And the more cars that drive over it, the harder that pack's going to be. And it's more than 4 times as expensive to remove that hard pack, and a lot harder on equipment than it is to keep that bond from happening in the beginning. So we're going to, anti-icing is not about the timing. It doesn't just mean pre-treating. Anti-icing can be done before, during, or after the snow. What it means is you're keeping ice from forming. So a lot of places, more and more, are starting to use all liquids and get away from granular completely because liquids will work. There is some understanding in how to do that, and you have to be able to get back to your property, your roads, sooner than if you're using a granular because you're putting down so much less product. But it's also far less expensive, which we'll get into at the end of this thing. So anti-icing, in my opinion, is the most important term and the most important thing we can be doing in snow removal. Saves you on equipment costs, it saves you on material costs, and it saves you on labor. And I've had a lot of people say, well, yeah, but then my guys are all tired when the snow comes in because we've been out pre-treating. And here's the thing about using straight brine especially, and I don't know if I have any guys from Wyoming on here, but I've had many conversations with some of the DOT in Wyoming, a couple of the cities. When we put down straight brine, you're preventing that snow and ice from bonding. And when you use salt brine for that and the temperatures get really cold, it's not going to cause the snow and ice to stick to the road because it's not melting anything. Now, if the temperatures are warmer, yes, it can do that. But we can talk more about that as we go on. And if you guys have questions on that, please just put that in the chat because we can address that further, especially, so I cover the U.S. and Canada. There are markets in this country where 80% of our storms start as rain. Probably my biggest users of brine are in those markets. So rain, freezing rain, I know some of your studies are going to say don't put it down if you're going to get rain or freezing rain, and I'm going to disagree with those studies on that because I don't think people are doing it in the right way. I've seen success with both of those. And when you put down straight brine in a pre-treating format, you can put it down days in advance. So your crews aren't tired when it comes time to go out and fight the snow because they put it down 3 days ago. And it's not going to stay wet. It actually dries and gets down into the surface and pre-treats that surface. I'm going to use this picture. It pre-seasons the surface, just like if you were using a cast iron pan. And I use this all the time. If I cook with my cast iron pan and I only have treated it one time, I'm going to get some stickage, not a lot, but some stickage. I pre-season that pan probably 7 times before I use it. And then I can take a paper towel and just wipe it out and put another little seasoning on it, and it's good to go for the next one. I never need to wash that pan. If I do wash it, it's just with pure straight hot water. Now, I have had conditions where someone in my household, I won't say who, would take that pan and put it in the dishwater, and I'd have to start all over again. So actually, your surface is going to be the same way, guys. From what I have seen in the past 10 years of doing this, the more of a pre-treatment that you get down, whether it's one time or 7 times, the better your surface is going to respond to whatever falls on it. Even a heavy rain is not going to wash that brine away, not totally at least, and you're still going to get the benefit of putting down that pre-treatment. So it can be done at any time, pre or post. De-icing then is obviously the opposite of that. De-icing is once we have ice, what do we do with that? It's a reactive instead of a proactive approach to snow. And those of us in the contractor world always had these contracts that said, don't do anything to my property until there's an inch of snow. And I know a lot of you guys in the public works world kind of have viewed it in the same way. Well, we can't go out until we get some snow on the surface. And you may start as soon as it starts snowing, but obviously you're not going to get to your whole region before you have an accumulation of snow. That would be our de-icing approach. We are going out after we've plowed, after there's been snow. In most cases, there's been hard pack, and now we're treating that. And that's going to be done primarily with a granular, although we are going to talk about how to do that with liquids here in just a little bit. So DLA, direct liquid application, this means you're putting your liquid directly on the pavement and not on the salt or the sand. You can do those, but that's what DLA is talking about. Pre-treating your stockpiles is a great way to start. If you have not done that, I would never, ever, ever put down a dry salt. It's just ineffective, and we'll show you some numbers. Pre-wetting your salt, you're putting it on at the spinner. It's a great way to do it too if you're using rock salt, especially if you're doing post-treating with a rock salt. I would be doing either pre-treating pile or pre-wetting or both. You can do both. We're not going to talk about best management at this point or limb costs. We can get into that further if anybody wants to. Dilution, we will talk a little bit more about that as we go on. Cycle time obviously depends on your situation. I defined a lane mile and an acre here. So a lot of you, I will ask you how many lane miles you have, and a lot of you answer me in how many center line miles you have, which I understand and is okay. But for those of you with DOT, in some places you got 3 lanes instead of 2. So really, we need to kind of do it in lane miles. Everything's calculated based on lane miles. 3 reasons to use brine, in my opinion. It's the safest thing we can do as a snow fighter because it's instant. As soon as moisture hits it, it's working. Where my first time of putting down rock salt, nobody told me it takes 20 minutes, 30 minutes, depending on the temperature, to start actually melting snow. So I put 6 tons on 1 acre. I've learned a little bit since then, but that was my first attempt, and because nobody told me. And so the nice thing about brine is you put it down, or any kind of a liquid blend, you put it down and it's immediately melting snow and ice as soon as it hits the surface. So it's the safest thing we can do. Secondly, it's the most environmentally responsible thing we can do. With brine, and I'll show you these numbers as we go on, but you're using about 1/10 to 1/4 as much product as you're using with a granular product. We'll go into that deeper. And then thirdly is the huge cost savings. And when I say huge cost savings, when we go at the very end, we're going to talk about this in real numbers. When we do that, just think of it in terms of a coin. One side is savings, one side is profit, depending on what you're doing. If you're in the private sector, you're talking about profit. And if you're in the public sector, you're talking about savings. They both are the same thing. So let's spend a couple slides here on the environmental aspect. 1 teaspoon of salt permanently pollutes 5 gallons of water. 10 yards of salt pollutes 8 million gallons of water. According to what I could find here a couple weeks ago, I kind of looked up these numbers again, and it looks like the U.S. is using about 24 million tons of salt. So imagine how much water we're polluting, and unnecessarily. Not all of it's unnecessarily, because people say, well, why do we use salt? Why don't we use something else? Well, because nobody wants to pay for something else, number one. Number two, you have to use something. And they say, well, we didn't use anything back in the 60s when I was going to work. And I said, yeah, but there weren't a billion cars on the road driving at 70 miles an hour, or if you're in Chicago, driving down the left-hand lane at 100 miles an hour. I mean, so things have changed, and we have to have something on the surface for safety. And so salt's not going to go away, but we do need to be more responsible with how much of it we're putting down. And a lot of times public works, you guys are putting down salt pretty much every time you drop a plow. Nothing wrong with that. We just need to be responsible in how much we're using. The other problem is, in a lot of cases, we pre-treated with granular product. As soon as it starts snowing, you run the plows out there. That salt hasn't even had time to work at all. And so you're just plowing it off the road into the ditches, and it's running into our water supply, our lakes, rivers, and the groundwater. New York, this lake in New York, Lake George, gets about $1 billion of tourism a year. This lake is almost tipsy as far as its amount of brine. So for 10 years, I had worked with them for the first few years in trying to convert the communities around this lake to using brine. And we loaned them a brine maker or two for a few years to try it. They're finally starting to get a handle on it, but problem is this salt gets into these lakes and it kills the flora and fauna in the bottom of the lake. The fish have nothing to feed on, and before long the fish are dying because of that, let alone the fact that they die from the salt exposure itself. New Hampshire, their runoff was enough that the state law made them not be able to open an $800 million expansion. This was finished, and they still couldn't use it for several years because of the runoff of salt in New Hampshire. New Hampshire is very aggressive on the environmental side of this thing. And you can see from this, 50% of that's coming from parking lots. The other 50% pretty much is coming from the public works areas. So there are a couple of little things in there like water softeners, things like that have some salt. But so you can see here on the Ontario River, it was tested at 20,000 milligrams per liter of chloride, and chloride levels above 800 are harmful to most freshwater fish. 1,000 milligrams per liter is lethal to rainbow trout. So I would say probably all of us on this call are somewhat conservationists, environmentally friendly, maybe not environmentalists, which I don't consider myself an environmentalist, but I also don't want to see our fish killed in our rivers and streams, and then the lakes and the underground water. I was just in, what city? I can't remember the city. In New Hampshire, has 3 water wells. They had to close one of the water wells, so a third of their city water gone because of salt in the groundwater. So this is a big deal all over the country. Some states are more prone to this than others. Fortunately for you guys, you're in states that are not highly populated for the most part, so this isn't as big a deal. But all over the country, this is becoming a bigger and bigger deal. So the other part of this is, notice with calcium, you have 2 parts chloride to 1 part calcium. Magnesium, 2 parts chloride to 1 part magnesium. Sodium chloride, 1 part chloride to 1 part sodium. And as we know, it's the chlorides that are harmful to our bridge decks and the metal in the concrete, in the highways, etc. It's the chloride that damages that. Now, Iowa's done a study that says that limestone concrete is also damaged by magnesium. Beyond the chloride damage, the magnesium itself damages limestone concrete. So those are the things you need to know as you start thinking about how do I blend this stuff. I used to have contracts where they would say, you can't use salt. It's too corrosive. You got to use calcium. Well, it took a scientist in New Hampshire to point out to me after doing these seminars for, in New Hampshire, I was a certified trainer, and as an 8-hour seminar, they pointed out to me after seeing this that there are 2 parts chloride in calcium and magnesium and only 1 part in sodium. So to say that calcium is more that sodium is more corrosive is just pretty hard to swallow based on that fact. Then I've developed a relationship with a manufacturer out of Denver. There's also one in Iowa who make non-chloride products. Product out of Denver is called New Deal. It's a totally non-chloride product with a sodium base. So it has the same temperature parameters basically as sodium chloride, but there are no chlorides in it. It's built for airports, but it's great for new concrete and sidewalks. And it works great for anything. It's just that it's more expensive, but it's about 1/5 the price of the product that comes out of Iowa that most airports are using. And most airports are using it because they were the first one. They're the biggest one. I'm assuming they also have lobbies, but and it's a product that works at lower temperatures than the New Deal. But if you're needing something to put on new concrete, you can blend this with the others and still not have chloride, and it's a great item. So you have several choices here when it comes to chlorides. So our mission as snow fighters, whether public or private, is to use as much salt as we need to provide safe, dependable surfaces for the public during the winter, but not 1 pound more. And you guys in the public works may have had the same issues that we've had in the private, which is we had private companies say, unless I see salt looking like snow on the parking lot, you don't have enough salt down. And I know the public can be pretty complaining about some of the same things, but the truth is it doesn't matter. We cannot continue to do that. And we are seeing the tide change. The biggest retailer in the country called me about 3 months ago and said, will you do a seminar for our contractors? Because we've experimented with using brine and we've never had better results. And we're not dragging the product into the building and ruining our floors, et cetera, et cetera. And they gave me 2 days, and 2 days later, they had 800 contractors on that call. So the tide is changing on the expectation of what we do. And it's always that balance between safety and environmental and costs. So just another quick picture of this. This is our small pickup sprayer, putting it down these obviously flatbeds with our high flow electric motors. So again, we have high flow electric, we have gas, and we have hydraulic. But nobody else has been able to come up with an electric motor that can put down this kind of volume. For pre-treating, let's say you're putting down 30 gallons per acre per lane mile. We can do an acre or a lane mile a minute with that electric motor. So that's a little deceptive. You got a 3-lane, you're obviously you got 3 lane miles. It's going to take you more than a minute. It's going to take you 3 minutes, but that gives you an idea of what the production rate is. So 5 times to use brine, anti-icing or de-icing, DLA. Direct liquid application. Second would be pre-wet, liquid applied to a solid product as it comes off the spinner. Number 3 would be pre-treating your stockpiles. Very simple, easy, and huge benefits. Number 4 would be slurry. Slurry is where we're putting on more than 10 gallons a ton so that the salt is not absorbing all the liquid. It's actually coming out partly as a liquid, kind of more like a molasses. And as far as I know, there are guys doing up to 50 to 60 gallons per ton. The problem with slurry is the equipment's very expensive for it. So Our goal as snow fighters is to get your surface wet or slush. With your coefficient of friction, you're looking at 1.7 to 2. If we wait and we do not pre-treat and you start getting hard pack, you are down to 6 to 7. So you can see from this why our costs are so much more if we do not pre-treat. It's not just 50% more, it's a lot more. So let's talk for a minute about anti-icing, and I'm going to guess that probably these are not new things, new ideas to you guys, but just to make it clear, left-hand side upper picture, that you got pre-treating on the left, non-pre-treating on the right. So on the left, you've got slush or water under those footprints. On the right, you're going to have ice. And of course, the more traffic you get on it, the more ice you're going to have. Same way in the bottom picture, the left-hand side is going to start turning to ice. The right-hand side is going to be liquid. Here we have the same thing. Pictures taken about 10 minutes apart from each other in the same area, same property. Pre-treat, non-pre-treat. Again, the same. Anti-icing is the most environmentally safe, cost-effective practice in winter maintenance. It requires about 1/4 the material and 1/10 of the overall cost of de-icing. Anti-icing application. I mentioned electric motor is going to give you about 32 gallons a minute, gas motor anywhere from 50 to 70. Hydraulic motors, 80 and above. You can, some of these, I think you can get over 100 gallons a minute, although I don't deal a whole lot with hydraulic. Obviously, DOT and bigger cities, you probably have hydraulics on your trucks. I'm finding a lot of the new public works are buying trucks without hydraulics just because of the expense of it. And so even some of those are starting to use our electric motors. And then anti-icing application, you can see from the picture here, we're running with this boom, we're running stream nozzles in the center and heavy droplet spray on the side. We also have a highway boom that has streams down the center, and then we run up the side here where you get streams off the side as well. So if you like to run all streams, we have a boom for that. It's an upgrade because it's a stainless steel boom. So again, you can see the kind of volume we're putting down. And the same thing here on highways with, this is not a stream, this would be more of a heavy droplet application. Let's talk de-icing for a second. So now we're talking about where it has already snowed and they did not pre-treat. So there's a city, Farmington Hills, up in the Detroit area. It's been using brine for 15 years, I think now. And they're a huge, they do about 3 million gallons a year in this fairly small community. So they're huge into brine and liquids. What this picture is showing is you've got a roundabout and they're coming down the left-hand side with the plow, around the right-hand side with the plow, and then they treat it after they've plowed it. So if we were live in person, I would ask you, and so just in your mind, which side looks the best? Which one looks like it's responded best? And I will tell you that 95% of the time when I have show of hands, they think they look about the same. Sometimes someone thinks the left hand or the right hand is better, but honestly, it's overwhelmingly about the same. Here's the difference. On the left-hand side, they applied at a rate of 350 pounds per lane mile with 18 gallons of liquid on it. Road temperature is 22 degrees. Same temperature, obviously, on the right-hand side. The difference is they used 60 gallons of liquid, straight brine. Now, here's the magic numbers. On the left-hand side, they would use 357 pounds of salt per lane mile at $12.05 of cost per lane mile, with their salt being $70 a ton. On the right-hand side, they would have used 138 pounds of salt at $4.83 per lane mile, with the salt being $70 a ton. So my question to you guys is, if you can get the same result and spend a third as much money, why in the world would you apply like you did on the left-hand side here rather than the right-hand side? And I'm going to say there's two reasons, possibly. Number one, you didn't know that, and that's a very big possibility because people don't know that. And number two, maybe you just don't have the equipment to do it. I can't think of any other really legitimate reasons why you would use more salt than is necessary to accomplish the same end. This one is another picture I love to show because we're getting under that threshold of 15 degrees. Notice here, pavement temperature 11 degrees. They used a blend, 80% brine, 20% snow melt, which is a blend product. And you can see after 3 hours, this is all melted with the exception right here. And when I ask why, pretty much everybody says because of shade. And I'll just say, yes, but there's a deeper issue. It's because of pavement temperature. And the shade causes the pavement temperature to be cooler. But if there was a culvert under here or something like that so that your air temperature was getting under the road, you'd have the same issue. So it's really because of pavement temperature. But notice on this one, you had some traffic. So you had some snowpack. It wasn't icy, looks like, but within 3 hours, it melted it clean. So you can do de-icing post-treatment with brine, but I will tell you, you've got to be more careful for sure. And I don't recommend necessarily, if you've never put down brine before, starting with post-treatment. I recommend starting with pre-treatment, and you'll learn a lot how brine works, and then you can start doing it more and more. And you will probably. If you stick with it for the first couple of years, you're just going to put down more and more and more brine and less and less and less granular. And you can see on a sidewalk here, same thing, got snow all over the place, treated it with liquid, and you got pretty good melt going on here. You still have a little bit of ice down in here, but that'll melt off too. So let's talk about effective and efficient. See how I'm doing on time here. Okay, effective and efficient. So here on the right-hand side, we have a liquid-coated granular salt. Left-hand side, just salt, and this is at 5 degrees. So you can see even at 5 degrees, the liquid-coated salt is just killing it compared to the regular salt. 1 truckload of salt will produce approximately equal to 4 truckloads of brine. Each truckload of brine will cover as much ground as 4 truckloads of salt. A little bit of a confusing picture, but I like what it says. Let's look at it in a little different format. On this one, 10 tons of salt at 300 pounds a lane mile gives you about 67 miles. At 20 gallons per lane mile for liquid, 435. Those are both pretty light application rates, but you can see the comparison. How much more you're going to get out of the liquid. Science and the art. 2 primary factors that affect application rate decisions. Number 1, pavement temperature. How cold is your pavement? Number 2, moisture. Big factor. And I would say for some of you, North Dakota, Wyoming, parts of South Dakota, another factor here that a lot of the country doesn't deal with is wind. But does your road freeze based on wind temperature? Absolutely not. Does the wind affect it? Absolutely it does. I have a great story about that, but I don't have time to tell it right now. So these are the states in the darkest blue where you struggle with the really cold temperatures. Lighter blue, lesser problems, but North Dakota, our plants up in Niche, whew, I don't even want to talk about how cold it gets up there. Northern Wisconsin, same thing. I mean, actually a lot of Wisconsin gets this same issue. Anchorage, Alaska, they would scream at me about their temperatures and permafrost. The most effective snow removal I found up there were the couple companies who converted to liquids. So it really doesn't matter the temperature. You just have to be cognizant of it and then base your program around that. So interesting chart here. Wish I'd have had it when I was a contractor. At 30 degrees, 1 pound of salt melts 46 pounds of ice. At 0 degrees, 1 pound of salt melts 3.7 pounds of ice. You can see even at minus 6 degrees, it's still melting snow and ice. It's just not effective because it melts it so slow. Interestingly enough, if you had a lane of calcium, lane of magnesium, and a lane of sodium with a temperature of minus 4 degrees, and you had snow on it, the calcium and the magnesium would have done all their work. This was within a 24-hour period. Calcium, magnesium would have done all their work and refrozen. The sodium has melted more snow and ice than either the calcium or the magnesium and is still melting snow and ice at minus 4 degrees. So when we talk effective, sodium has amazing traits. The problem is at those really cold temperatures, it doesn't do it quickly, which is why we blend it with a calcium or magnesium or a different blend, maybe some beet juice, some different blends. So most important thing about brine, we need it to be 23.3%. 2 reasons. At 23.3%, you see here, it has the exact same melting temperatures or melting point as rock salt, minus 6 degrees. If it's more than 23.3%, notice like I called on a DOT, I'm not going to say who, but a DOT that says they make theirs at 26%. Well, if you notice from this chart, 26% is going to freeze at about 32 degrees. You don't want to do that. You want your brine 23.3%. If you may have a few tenths of a percent variable here, but I suggest guys check their brine 2 or 3 times in the making process to make sure that the brine coming out of your storage tanks is 23.3%. Second reason, water will only hold 23.3% brine. When it gets above that, the salt falls out of solution and you start getting sludge in your tanks, sprayers, etc. So keep your brine at 23.3%. Ways to do it. It's not that hard, but that's it, hugely important. We'll talk about dilution here in a minute. So here we have the freezing point for each of these chemicals, and you can see sodium chloride's the highest. But notice here, calcium chloride, when it's 50% diluted, melts at 10 degrees or freezes at 10 degrees. Magnesium chloride at 15, sodium chloride at 18. Sodium chloride has the least change by dilution as these other chemicals. But we don't want it to get 50% diluted. We really don't want it freezing at 18 degrees. So how do we know? This is the art. This is purely art, guys. Now, I have seen a piece of equipment that's come out. I'd only seen it for the first time last year that can tell us what the coefficient of friction is on the road. It can tell us how much ice is there, et cetera, et cetera. I have not had a chance to talk to anybody who's used it. But up to this point, the only way we know how diluted it is by experience, by testing it, by trying it, by doing it. That's how you learn. Again, I use the example of my daughter who still dances, but she was a professional ballet dancer, and she used to come home as a kid with bloody feet and just crippled almost. And I would just go, why in the heck are you doing this? And it was so that she could perfect her art. And she has. Now she's theater and dancer and singer. And the only way you're going to get good at brine for any liquid is by actually getting out there and doing it. Will you make some mistakes? Possibly. Hopefully not big ones. If you start doing it in a small way, hopefully you make your mistakes, if you're going to make any, in the small way and not in a big scale. This one just talks about all the different parameters. It'll be in the presentation if you guys decide to get the presentation. Here we're talking about blending. So suggestion from contractor that I know that's been doing this about 20 years. From 32 to 15, he uses straight brine. 14 to 5, he uses a 80-20 blend with calcium being the 20. And colder than that, he uses a 70-30 with calcium being the 30%. And now he's in Minnesota, really, really cold temperatures, probably similar to what a lot of you guys would face. So these are kind of important as far as your blending ratios. It is subjective, obviously. So what do I suggest as far as pre-treating, anti-ice pre-treatment? So the different scientific studies that you're going to read are going to suggest somewhere, and I have a little bit of friction with a couple of these science groups. I'm not going to say who, but they're suggesting 18 to 25 gallons for pre-treatment. And I said, guys, that's all cool in a laboratory. But when you put it out on the road, we have to have these roads clear. We can't be waiting for things to happen. So what I found is I'm selling a lot of stuff right now down in Dallas and Texas. So in Texas, we're running 18 to 20 gallons for pre-treatment. You get up to, let's say, Highway 40, Interstate 40, we're probably running 25 to 30 gallons. You get up to I-70 where I live, and we're running more like 35 to 40 gallons. Omaha, 45. When you get up north of there, I'm finding guys running 50 to 60 gallons. So, you get up into North Dakota there and Wyoming, some of your places where you got the really cold temperatures, South Dakota, even parts of Nebraska, different places, you probably going to be wanting to run anywhere from 45 to 65 gallons per lane mile for pre-treating. Now, if you really, really want to cover it, which I really like the idea of, and a lot of guys out east are doing this, they're putting down several applications of pre-treatment, get more of it on the surface, and you don't put so much down at one time so that it's running off. It's actually getting into the surface of the road just a little bit, but enough that it's not going to wash away, and you're going to have it there no matter what kind of a storm you get, whether even an ice storm. And like I said, most of the studies, like the Clear Road study, will say don't put it down before an ice storm. I 100% disagree with that. But it's, again, that's me. That's subjective. But having talked to probably, I don't know how many thousand snow fighters over the last 10 years, I think it's a fairly accurate statement. Now, for post-treating, basically in most of our areas, we're saying double your application rate. Whatever you're doing for pre-treatment, just double it. And that's because now you have moisture you're dealing with. When you pre-treat, you're putting it down on a dry surface and you're letting it dry before the precipitation comes in. For post-treating, you're actually putting it down on a wet surface or an icy surface or a snowy surface. And so you're going to want to double that application rate and let that actually then work into whatever you have going on as a surface. Hopefully it's not a frozen surface, as in hopefully you've been able to pre-treat and get the ice so that it's not forming. But post-treating wise, since you do have liquid to deal with, water, you don't want it to dilute out, so you just put down more. I wish if this was open, I'd love to answer any questions you've got on that, but we'll keep going here for now. So lane miles serve 1 ton of salt. 1 ton of salt produces scientifically 870 gallons of brine, but that's going to depend on how pure your salt is. I've seen some salt down or out in California that came from Salt Lake that was 99.8% pure. My Kansas salt is about 90% pure. So, you can figure that, and I'll show you on an Excel spreadsheet here. I've got if you know the purity level of your salt, you can figure out how many gallons you're going to get out of a ton of salt. So if we're putting it down at 25 gallons per lane mile, you can get 35 lane miles out of 1 ton of salt. And I'll bet you none of you are getting that. And truthfully, in your market, you're going to be putting down more like 50 gallons. So cut that in half. But this, again, is just for an example to show you what can be done. So when you post-treat, I did this one at 60 gallons, 14.5 lane miles per ton of salt. If you're using a pre-wet and pre-treated salt, doing both, you're going to get about 8 miles out of 1 ton. If you're doing pre-treat or pre-wet, about 6. If you're doing dry salt, you're probably getting 4. So you can see easily there which one's the most efficient. Now, I won't spend any time on this slide because what I do here is I convert that to dollars for those that are in the private contracting world, see how much more money you can make by using your brine than your rock salt. But let's talk savings here for a second. So what we're saying here is, so there's 2.28 pounds of salt per gallon of brine at 23.3%. Your average application rate, let's say for rock salt, is going to be 350 pounds per lane mile. Salt costs $70. All that being the case, you are saving $9.05 and 207.93 pounds of salt per lane mile per application. I say this sometimes. When the speaker stops, that's an exclamation mark. All right. So I'm not going to spend any time on this slide other than to say, guys, I'm a 100% believer in that we have to become proactive with our approach rather than reactive. Now, I don't know how old any of you are. I don't see the pictures, but I will tell you this. Most oldsters like me who should be retiring by now but aren't, they're pretty hesitant to change from their reactive approach. The youngsters coming in aren't near as hesitant. And I'm pushing as hard as I can to say, let's become a proactive snow fighter rather than a reactive snow fighter for all the reasons we just mentioned. I'll just go through our equipment line real quick with you. This is not about Camion. I really wanted to spend most of this talking about brine and liquids, but just to kind of show you what we do offer. We offer through dealers. We can bid direct, whatever you want us to do. But so we have pickup sprayers. I have one of these in my pickup. We have sidewalk sprayers. You guys probably aren't going to be that interested in that. Highway sprayers. And you can see this one is our highway boom that has the tree on the side, so it sprays streams out of the side. More of your municipal county truck here with, say, 800 or 1,000 gallon tank on it. Then we have 2 different brine makers that we offer. So the question is, should you buy brine? Should you make brine? We'll talk about that here in a minute when it comes to cost. But we have a very inexpensive brine maker that we rate at 1,500 gallons an hour. We have another very inexpensive, higher volume brine maker. This one is rated at 3,000 gallons an hour. I've got guys getting over 4,500 gallons an hour out of this machine. Very, very competitively priced. And then you can see over here, we have UTV sprayers and we have bulk tanks. Camion came from a company, still owns this, called Enduroplast. Enduroplast is an ag company. We have been rotomolding tanks for in the U.S. for about 2.5 decades. We came from Australia, where we still rotomold tanks there. We have the only tanks on the market that are warranted for 10 years. So we have some major quality tanks. And when you compare our tank, looking at it to another, you can see the quality. If you want just the cheapest tank you can buy, you don't want our stuff. But if you want quality, both in the sprayers, the brine maker, and this brine maker blew me away because for years I've sold brine makers and automated systems. This is not an automated system. It's a manual system. And we can talk about what the difference is if you guys want to. And I'm 100% sold on the manual system after having done both now. So just a bunch of quick questions. How do I get started? Seem like an important issue for you guys. First question I want to ask you in trying to figure this out is how many lane miles you taking care of? And I want to know lane miles, not city or not center lane miles. How many lane miles are you taking care of? What do you anticipate as your pre-treating application rates? And so in that, I would ask you, where are you? Are you down near I-70, I-80, I-90? Where are you located? Are you in Wyoming, North Dakota, Nebraska? Those things to me will determine what I would suggest just as a guy. I mean, I'm not telling you what to do and I'm not your consultant, but I would suggest application rates based on those issues. What's involved in making brine? So involved in making brine basically are, oh, by the way, how many acres or lane miles? Well, the reason I asked that question is because that determines how much storage I'm going to suggest that you have. What your application rate is also will suggest to me how much storage you're going to need. Because I suggest to guys, and again, you don't have to do this, but I suggest that you have 3 rounds in your storage tanks. I used to apply sometimes 2 to 3 rounds per storm, and I wanted to make sure I wasn't making brine during a storm. You got enough other stuff going on. You don't want to be making brine during a storm. Make brine when it's 40 degrees outside. Don't make brine when it's 10 degrees outside or minus 10 degrees outside. Make it when it's nicer out. Put it in storage. Storage is cheap compared to all the problems you have when you are making brine in really cold and hard conditions. So what's involved in making brine? You need a brine maker. The size is going to depend on how much brine you need. Number 2, you need storage tanks. Number 3, you need a good water volume. If you're buying the smaller brine maker, you can do that even with a water hose. If you're buying the bigger one, I'm going to suggest that you have a 2-inch water line. You're only going to get out of it what you can put into it, right? So if you can get 100 or more gallons a minute with water, your chances of getting really good brine volume is good, really good. So do you have a bin or someplace where you can keep rock salt? If you don't and you're buying it in bags, then I'm going to suggest going with a small brine maker. If you have a loader and you have a bin to put salt in, great. That's all you need for your salt storage. What product do you use now? Are you using straight salt? Are you using a salt sand? Are you using calcium in your salt? What are you using now? You're going to need to know. I'm going to need to know. You're going to need to know what that is. And if you want to really figure out what it's going to cost you, how long it's going to take you to return on your investment. What kind of water supply do you have? Should you buy brine or make brine? And that one is a good question. I would say in most of the territory you guys are covering, you're probably going to need to make brine. It's too expensive to ship very far because of freight, transportation. I would say the average brine around the country is selling for, let's say, $1 a gallon. And if you're paying $70 a ton for salt, you can make brine at 80 cents a gallon. Or not 80 cents, 8 cents a gallon. So in some cases, it may pay off to buy it. And in some states, I've found DOT is willing to give brine to some of the municipalities or counties. I don't know how you guys work in those areas. Do you have bulk storage? In other words, do you have storage tanks? And if so, how much? Again, I'm going to suggest 3 full rounds in storage tanks. How many trucks can you set up with sprayers? And by the way, you don't need to convert all your spreader trucks to sprayers because you're probably not going to start out spraying everything. You're going to start out maybe by pre-treating and then using your solid product for your post-treating. That's what most people do anyway. This is another really important. What's the average cold night temperature in January and February? If your average cold night temperature is, say, 8 degrees in January and February, that's going to say that you're going to be blending product during December, January, February 100% of the time. If your average cold temperature is 16 degrees, it's telling you that probably 50% or more of the time you're going to run straight brine. And some people say, well, if I have to run blends during this part, I'm going to run blend all the time. Okay, fair enough. Here's the problem. Your exothermic chemicals can get slick when the temperature's warm. They're not as efficient. And we'll show you this when we start talking actual pricing here in a minute. Ooh, need to wrap this part up. What kind of ROI are you looking for? You know, in the private sector, I used to look for a 3-year ROI. But what kind of ROI are you looking for your city, your county, your state? Would you prefer to dive in or wade in? I'm a dive in guy. Probably not the smartest thing in the world. You get the choice of whether you just go whole hog or whether you try it and just kind of wade in. I will say this, if you're a wade in guy, everything is in a learning curve. So, you know, some of these guys that try it and it didn't work for them think the product doesn't work. Especially, I heard a lot of this from people who used it 10 years ago. I'm just going to encourage you. It works. Thousands and thousands of people are using it around the country. You just got to figure out how to make it work for you. So just some good and bad storage. You can see here, I found this in New Hampshire. You know, this was flapping in the wind and the salt was just getting eroded, basically. And here to drain, going right into the water supply. Here's some good inside storage. Here's some good outside storage. This company also has probably 30 of these size tanks around their salt bin, which is right here. You can see a yellow tank here. So they have lots of storage around their covered salt bin. That's good storage. Chemicals, all salt is the basis for pretty much all of the blends. People are using mag and calcium as well as some pre-blended chemicals. For example, beet heat is one, beet 55, Headwaters hot, and there are many others that are already pre-blended, which you can buy. And this will depend on the temperature and the goal you want to achieve. All right, so I'm going to stop sharing here for a second and try to figure this out. Wait, I don't need to stop sharing. Now I just need to, I think, if I go here, can you guys see that screen? Calculator? Anybody give me some quick feedback if you can see that?
Worksheet. The screen we're seeing is what's your number?
Okay, so you can't see, so I need to close this. Now can you see it?
No.
Nope.
You'll need
Okay.
to share that Excel sheet.
Okay, so let me see where I've got my Excel spread. Let's see, on screen 2. There. Can you see it now?
Yes, we can. If you can just
Okay.
make it larger view.
Do you want it to, you want the numbers larger on there? Can you see them okay? Or?
Yep, all you have to do is click on the maximize up on the right-hand side. Just make your screen bigger.
I think I made my screen bigger. Does it look bigger to you guys?
That's okay. We can go ahead and read it if you want.
Okay. All right. So what I've done here, guys, is you can get this sheet. We can get this to you. A little different than what I think you'll find from any other presentations on this, just because I was in the industry so long, I kind of know these numbers. So let's say you're paying $70 a ton for your salt. $70 a ton for your salt. Let's say your salt is 95% pure. Means you're going to get 826 gallons and a half out of 1 ton, which means you are paying 8 cents a gallon for your brine. If you go over on the right-hand side, I've put in some additives. Anything that's blue on this sheet, you can change. So if you had a different additive, you just overwrite one of these and put the price per gallon in here. And then you come down here and tell it what percentages you want. So let's say in this scenario, I wanted 80% salt, 10% additive 1, whatever that might be, 10% additive 2, which in this place is calcium, which I don't have any price in. So again, you just change these to match what you want where it's blue. And this is saying your hot brine is going to cost you 24 cents a gallon. So it's 3 times as expensive as using your straight brine. So does that mean you don't ever use the hot blend? Absolutely not. But does that mean you want to use the hot blend all the time because you're just too lazy to make both? I say no. I think you need to be having both. And what I always suggest, guys, is this. Never put your blend into your brine tank, because once you do that, now you've got to circulate that tank on a regular basis. You keep your brine separate, and your brine tank does not need to be circulated. That brine is good forever and ever, amen. You don't need to circulate it. But once you blend something else into it, you do. So I'm always saying blend it at the truck, and our machine will pull it out of your storage, both the brine and, let's say, calcium, pull them both out of the storage and put them in the truck. So it's easy to do, and it keeps you from having to rotate your tanks. So in this case, let's say you're applying 60 gallons per lane mile. That means you have $5.08 cost per lane mile. Down here on the hot blend, let's say you're doing 35 gallons per lane mile. You have $8.50 cost per lane mile. Now, if we step out of that for just a second, just to show you how much, in an 800-gallon tank, you're going to get 13.3 miles per load at 60 gallons. On my hot blend, I have it at 35 gallons. So on an 800-gallon tank, you're going to get 22.9 miles out of your hot load. So now if we come down here and say, okay, what's our current application rate with salt? And what I found with a lot of you guys in the public works sector is you might tell me what you're putting down per application, but your application could be 5, 6, 7 times in a storm. So what I tried to do here is say, okay, we're going to use 1,200 pounds per storm, which is probably light for a bunch of you guys because of the cold weather. You're probably closer to 2,000 pounds per storm. Let's just put that in here. And obviously you can change this to be exactly what you think you're doing. So what this is saying is at 60 gallons per lane mile, I'm saving almost $65 per lane mile per application. So how many lane miles do you have or acres? I said 1,000 here. Let's, this is going to vary widely because some of you are DOT, some of you are municipal. Let's just say in 150 lane miles, and you guys again can play with it. And let's say you're going to pre-treat every time. Every single time you're going to pre-treat. And so we're going to say 60% of the time you're pre-treating. What this is saying then is per event, you're saving $5,842. Let's say you have 100 events a year. Let's say 80. Again, this is going to depend on where you're at. So you're saving $467,000 a season. And again, when I first started doing these numbers, people said, those numbers aren't real. There's no way. And I would just humbly say to you guys, I don't know everything. That's for sure. A lot of what you heard me say today is stuff that I'm the only one saying. So I don't know everything. But you'll have to show me where my numbers are off if they're off. Anything that's blue is subjective, and you put in the numbers. All the other stuff is just pretty much science and the ratios and stuff. So show me where I'm wrong and I'll change it. I am not above learning. So let's say you went with our biggest brine maker, and our biggest brine maker is going to be somewhere in the $35,000 range, and you could do it with one brine maker. Let's say it took you 4 3,000-gallon storage tanks. For some of you, that wouldn't be enough. For some of you, that's more than you need. Again, you just replace, you can replace these numbers here too, by the way, I believe, unless I screwed up. So, and then the price is here per unit. And spray systems, again, it's going to depend on what you are using. If you're using let's say an 800-gallon unit, you're going to probably be in this range. And part of it's going to depend too on whether you go with the GPS unit or you go with an all manual unit. That GPS part of it adds about $5,000 to it. But when you do that, it not only controls the amount of brine you put down, it tracks everything you do and where it was put down, when it was put down, what truck put it down, and sends all that to the cloud. So that's what you get with the GPS unit. You're just adding about $5,000 to it. And we have many, many different sizes of sprayers, all the way up to, I think, 4,400 gallon. Smallest truck sprayers, 250 gallon. We do have UTV sprayers though too. So this is saying that your total equipment cost would be $144,000, and you're going to pay for it in 4 months. So again, all these numbers are subjective. Put in your real numbers, see where you're really at. But I can tell you this, it's the only thing I've ever done in business where I've seen the majority of people able to pay for all their equipment in less than a year. Now, obviously, you can buy it and not use it. It's not going to pay for itself. But if you buy it and use it to its fullest capability, you have about a third of a year you'll pay for that equipment. So one season easily, probably 1 month. So that's the end of my presentation. Denise, you want to open it up for questions now?
Well, with no other questions, we don't have any.
Very good. Well, thank you all for coming and listening to it. Denise, if you get any questions further, feel free to contact me. Love to help as much as I can.